Hello everyone, welcome to AI Anytime channel. In this video, I'm going to show that how you can fine-tune LLMs on multiple GPUs. Most of you would have fine-tuned on single GPU, single CUDA device, probably on Google Colab free version on Tesla T4 for 15 hours, or if you are on Pro, it gives you single GPUs like A100, L4 and whatnot. Most of you would have also used Kaggle notebooks. It also gives you some free GPUs to use, Lightning AI, and multiple others. Few of you would have used hyperscalers like SageMaker, Azure ML, and Vertex AI, and their notebook instances powered by a single GPU. And a very few of you, like 0.5 or 1% of you, would have fine-tuned on multiple GPUs. Now, it's important all of these LLMs that you see, Llama 3, Llama 2, and thousands of other large language models, they are all trained on something called multiple GPU, multi-machine, multi-GPU. So we're gonna only talk about multiple GPU, not the multi-machine part. Now, multiple GPUs are important when you have larger, like large data, humongous data like 100 GBs or not 100 is like too big. Even 10 GBs of data, you need at least couple of GPUs to train faster, to manage the compute workload in a better way. So that's what we're gonna see in this video. We're gonna use couple of Python libraries like DeepSpeed and Accelerate, and they're interesting. I'm gonna also try to cover, DeepSpeed a bit theoretically, and I'm not going to write any code. I already have trained this numerous times. Most of the codes that you're gonna see, not in my video, but all the other YouTubers. We don't kind of come up with 100% by our own. Most of these are available on Hugging Face documentations because they are the creators of this stack, and we then customize it. So don't think that if somebody is doing, completely that they completely own it. Nobody owns it, to be honest. So deep speed and accelerate. So let's jump in and see how we can do it. Now, so multiple GPUs, I can't get it on Google Colab and all of these things. So I am on RunPod here, a GPU provider, and I have some $10 left. So if I have $10, at least I can spin up couple of GPUs. Now to do this, and it's not a sponsored video, guys. Feel free to use whatever you want to use. Lambda Labs, RunPod, Vast AI, Pepperspace, SageMaker, Vertex AI, blah blah blah. Whatever you have with you, use it. If you have GPUs locally at your home, use it. But I'm gonna use RunPod because I love RunPod. It's one of my preferred GPU provider to do trainings. I do a lot of fine tunings and trainings for my own thing. Now here I'm gonna do is deploy a pod. Click on that. Pretty simple. Now it has two options, GPU, CPU. So we need GPU, so we'll just be on GPU tab. And then I'm gonna show you with L4 because I just want to show how it works. And L4 provides you 24 GB of VRAM, which is the GPU memory that you have, 24 GB and then 50 GB RAM, which having 12 CPUs. And I'm just gonna have this as 2. So just click on 2 because I don't want to take 8. Most of people take 8. If you want to do Llama 3.1 405V, how many do you need? 8 into 8 800. Not 8 into 8 800. Recently I trained on 8 into 8. You need 8, at least 8 800. And then again you have to do bits and bytes and stuff to load it. Okay. But here I'm gonna keep it 2 because we wanna try with a very simple models and stuff. Okay. Now you can see this is how it's going to cost me, guys. $0.86 per hour. Now I'm just gonna click on deploy on demand. Now deploy on demand is working. I'm gonna show you my GitHub repository. I already have this, so I'm gonna give you this. Pretty simple, and I'm just gonna download this here. So I'm just going to upload this bunch of files. So let me just extract this thingy here. And once you extract it, you're gonna open this here. This is what we have. Come back And then you can see our GPUs are up and running. I'm also gonna open Hugging Face because I have to show you a few things. Okay, let's expand this. And you can see I have expanded it. It's still working, downloading. It has to download the templates, guys, because it will give you all the libraries installed, like PyTorch and everything that you need. It will be GPU enabled and blah blah blah. So everything will be configured. So you just have to use this notebook and start installing it, installing the libraries and work with it. Meanwhile, it's happening, guys. We're gonna use DeepSpeed and Accelerate. That's what I said, right? So first of all, let me take a keys here. I need an access tokens, guys, and they have changed a bit. I'm gonna create a new access token. Of course, I will delete this after the video. So I'm just gonna do demo and probably run pod, create token and copy it and done. And I'm gonna keep this in a notepad here. So I'm just gonna keep this in notepad and yeah, and then just paste it here, keep it handy. You can see Jupyter Lab started, blah blah blah, and it will be able to connect now in a bit. Takes a bit of time depending on how much bandwidth they are facing, at a given time. Now we're gonna use couple of models. So let me open the model tab and a datasets tab. So model tab, it's opening, and I'm gonna use Gemma 2B. We can use Gemma 2B. You can also use Tiny Llama if you are not aware. I just want to show you with a very small LLM because I don't want to bear a lot of cost because I only have $10 left on RunPod. I don't want to use all this bigger thing. Okay, now Tiny Llama. Okay, so how do we search Tiny Llama here? Why it's not showing me Tiny Llama? Okay, so we're gonna use this Tiny Llama here. Okay. Model with only 1.1 billion parameters, tensor type BF16. That is good. That's fine. That's fine. Uh, let's connect to Jupyter Lab, and then it takes a bit of time. Something looks a bit slow. Okay, but yeah, this is how you connect to Jupyter Lab. I'm just closing it. It has 20 GB of disk and 20 GB of pod volume that you see it over here, and everything is saved in workspace. And I'm just going to delete this, cut this, and again connect, and then open a notebook. Takes sometimes, depending on, as I said, right, the availability of the machines, and you can see our Jupyter Labs are up and running, and gives you an environment to work with, guys, which is great. Okay, now let's wait for it, and I'm just going to upload a bunch of files here. Multi GPU. Let's upload all of this. Not required. Okay, so train untitled DeepSpeed config, and I uploaded 3 files. I'll give this file. Now you can also generate DeepSpeed config. There's an command. I can give the link in description. I'll give the command in description how you can generate this config .yaml file for DeepSpeed. Now we're going to talk about DeepSpeed before we go into training and all. That's not the important part. The important part for you to understand why DeepSpeed. Now, at least let me start installing this because this thingy will take time. So we need accelerate, we need transformers, we need parameter efficient fine tuning, pip, deep speed, transformer, TRL, bits and bytes, flash attentions, and if you want to install flash attention, you have to do no build isolation. Okay, guys, now let me show you this data set. There is a dummy data that we have on Hugging Face. So you can take any data, but I'm going to show you how you can deal with data sets. This is a healthcare data that I have. Doesn't matter. That's data and models are not important for this video. For this video, for you to understand how you can use setup and all these things in your infra, and you can start training it or fine tuning in rather. We're not pre-training, by the way. I don't have the ability right now. When I say ability, it's not about the knowledge, it's about the compute and resources that I don't have. I might go bankrupt if I tried doing pre-trained modeling. So it will take a bit of time. Now let's jump in and see what is deep speed, guys. Here you see a deep speed file, something called deep speed config, Z3, which is 03, and we're going to talk about the redundancy operations. Okay. Now let me open this. I already have some notes for you already. I'm not going to write this. I have created this for you. I'll just explain a few things. Now, DeepSpeed is a Python library that helps you, with multi GPU fine tuning or multi GPU training of AI models. It's not only LLM, you can do a lot of other things. Now, it provides you memory optimizations. The reason being because it has the ability of gradient checkpointing, memory swapping, and offloading. Now, I'm not explaining this part by part because I have couple of videos on hyperparameters, explaining all the hyperparameters, how these techniques works like gradient checkpointing, GPU parallelism, and then it has offloading. So you offload on different GPUs, or even CPUs, depending on what you are doing. Then we have zero optimization. So there are three different types of stages when it comes to zero redundancy optimizations or operations optimizations. Now, redundant, when it means it has three different stages, optimizes the memory consumptions of states, gradients, and parameters. So we're going to look at zero stage 3. Now the stage 3, the reason being because we're going to optimize the model weights, memory consumption of parameters. That's what we're going to optimize. So we're going to use stage 3 that you see. Now DeepSpeed also provides mixed precision technique, both F16 and BF16. So you can see 16-bit and 32-bit over here. That's what we're going to do. And it also provides pipeline parallelism and tensor slicing. So tensor slicings are nothing but if you have a large tensors, it creates smaller sizes of tensors and distribute on different GPUs. So GPU1, GPU2, GPU-N. That's what the tensor slicing is. So it has all of these features inbuilt into DeepSpeed, guys, and that's what we're gonna do in this video. So we're gonna use DeepSpeed to basically fine tune Gemma 2B on two GPUs on a given Hugging Face dataset. Now, this is how the config looks like. So the compute environment is a local machine. I have debug false and couple of utils here, offload optimizer, keep it all none. You can just use this file to do it. And you can see I'm using zero stage, which is 3. And I'm saving the 16-bit model, which is true. Distributed type deep speed downcast VF16. And this is where number of processes and number of machines and mixed precision. These three things are really, really important. Not all models supports BF6. Not all models supports BF16, and not all GPUs support BF16 as well. So if you are really using, if like Ampere, for example, supports BF16, L4, for example, supports BF16, but there are few GPUs which don't support BF16, then you cannot use that in that case. Now, number of processes means how many GPUs. So I'm saying two, and machines are being one. So you can also do multi-machine, multi-GPU. So you have multiple nodes, and you can also do that training. But I'm not doing it because I don't have that currently with in this machine here. Now number of machines once and number of processes two, and then you can ignore this for now. Okay, the TPU thingy is all false. Now this is a deep speed config file, a pretty standard config file that you can use it for your fine tuning and stuff. Now you can see we have installed this. Now here is an accelerate command that we are fine tuning it. Most of the SFT code that we have, if you do supervised fine tuning, you will know all of this. But let me show you train.py. Now in train.py is the file where we define all of our models, define all the pre-processing strategy for your data, how to pre-process data. So first let me show you. So it has a class called model arguments. Argument pertaining to which model config tokenizer. So all of the processes will happen here. Your models, your data, your templates, and everything. Now model name takes it from here. You can see, and it has some chat template, couple of chat templates that is had, and we have all of your thing LoRa because we're gonna use PIFT. So your all the hyperparams and the LoRa config that you have. So you can see alpha, dropout, R. All of these I have explained in my fine tuning crash course video. Watch that. I'll give the link in description. We have our bits and bytes 4-bit compute. You can look at everything that has been defined. If you want to use flash attention, not all GPUs support flash attention. So we are on GPUs which supports flash attention. So we are using it. We have PIFT, LoRa, 8-bit quant, everything has been defined, and it's our argument parser. So you can give that here, in this thing here. I'm going to talk about that. Now, After that, we have data training arguments. So we're going to deal with the data. So you can see if you are not giving any data set name, it will use Open Assistant Guanaco for other default data sets over here. And if you have your own, then it will look at the data set text field, which is going to be a text. And then it has a lot of pretty standard things, guys, adding the special tokens and looking at making a trend test split because it has to create an evaluation split. And then your main function where we're going to define the model, pift, config, and tokenizer. We're going to load the model, create and prepare model, which is again, if you look at here, create and prepare model coming from utils. We have utils.py. So let me just go to utils. Now in utils.py, py that we're going to just define our different template, chat template, just for make the data a bit instruction tuned, where you can give instructions and all. You can see we have chat ML special tokens, Jyfer special tokens, and then we are creating the data sets. This is the function where you should this is the function where you should do necessary pre-processing steps based on your data set. So if you take any other data sets, then here is thing that you have to make change. For example, if you don't have a test split, and uh, if your column name is not text, or if it does not contain, for example, if you come here, it does not contain messages, in your data sets, then this will be a problem because it says for conversation in samples messages, then you have to change it over here. So you have to be a bit careful, if you are using some other data sets. If you get any error, so first thing that you have to do, debug the error and make sure that you are pre-processing the data in the right way for fine tuning. And then this create and prepare model where we have our you know bnb config coming in. We have our we are using unsloth to do that, and a lot of other things that's happening here. You can just look LoRa and everything the same thing. So this is an utils file, and we're just calling this in train.py, and then the same thing is happening here now in untitled IPUNB file. Now what we are doing, we are saying accelerate launch config file, and then giving the path of this DeepSpeed config jet3 QLoRa YAML. That's the file name. If you have other file name, make sure to change this. Train.py file, and then your seed, and then I'm giving the model name, so which is tiny llama, medical dialog to soap summary, chat template, special tokens, false. My splits is train test. If you don't have a test split, you're just gonna keep train split here. And then I'm keeping max sequence length, number of train epochs 1. You can increase the epochs if you have multiple GPUs, this would do that. And pretty much hyperparameters, guys, over here. If you want to do vendor B, you do it, weights and biases, loggings, save strategy, epochs, BF16 true because we are relying on BF16, and output directory, you can see it over here. And per device batch sizes, increase it if you want, and some of the LoRa config, the LoRa arcs, and then yes, and you can look at over here, right? So that's what we're gonna do, to be honest. Now I'm gonna run this and show you a few things here. So it takes a lot of time. Uh, it might take you hours depending on how big the data, even if you're on multiple GPUs. I have seen fine tuning or training where I have to wait for 3, 4, 5 days, to go through it because we have humongous data sets. So you have to wait for it. Now you just have to run this, and then it will do a lot of things. First download the model, then load the model in memory, and then download the data, then map the data, and then start fine tuning. So it takes a lot of time. So now you just have to run it and then wait for it to see if this is working. Now as you guys can see, it started fine tuning it on multiple GPUs. So let me show you how it works. You can see it over here. It says number of examples 6,611. Not a big data set. Number of epochs 1, batch size per device 2, gradient accumulation steps, total optimization steps. Now if you go up, you can see it over here. Everything. All the logs, verbose descriptions have been printed, and I want to show you that what happened completely. You can see all the model pipeline, the model architecture layers. We also printed sample. You can see map 100%, so data was mapped. Size of the train set 900, 2050. Size of the validation set 250. And you can see we have also loaded the model, and it's fantastic. Right now we are fine tuning it on multiple GPUs. You are basically fine tuning, guys, on a multi GPU on your own with a very good data, by the way, on any healthcare, and you can bring up your own data in a similar format or any other format. You just have to do the pre-processing. If you don't know anything about pre-processing, chat gpt use chat gpt, Gemini, or Claude. Give the data structure and ask it to give you the code for pre-processing. That's how you learn, guys. If you have any questions, you can also ask me in the comment box. Reach out to me through my social media channel. If you don't understand deep speed, if you didn't get anything, it's fine. Just try it out. I'll give the code on my GitHub repository. Try it out on the same data, and then you will understand. Once you understand on the same data, you can use any other data, any other models. Here you have to do a bit of tweaking. Some models might not support a projection layer, like llama 3.1 don't support a particular projection layer that llama 2 supported. So in those things you will learn it. You first have to start. Okay, so take these same notebooks and everything, invest $2 to $5 on RunPod, do multiple GPU fine tuning, and then you go into larger projects and whatnot. That's how you learn, guys, trust me. So I'm just gonna stop this. I don't want to burn my money here. But I just show you that this is working. There is no, editing and all. To be honest, this is how it works in real world. It's working. Once it is fine-tuned, I can just save the load adapters, or I can merge it and then save it on Hugging Face and then start using it. It becomes my own model, to be honest. So it's easy, guys. It's easy. Not a lot of hype going on. Don't believe in hype and all. Okay, start learning, fine-tuning real things. Stop wasting time on a lot of building wrappers and all. Okay. That's all for this video. Let me just stop this sit here. Okay, so I'm just gonna close this leave, and I'm just going to close. How easy it is. Stop port and immediately delete it. You see this immediate delete. So it just costed me like $1. It costed me $1, and I've shown you how you can do it just for showing it. If I keep it for like 2 3 GPUs, it would probably costed me $10 to $20 for a fine tuning on multiple GPUs on a very good data set. So uh just start. You have these theories and all. If you want, you can give this, join our Discord community, join our WhatsApp group. I'll give the link of Discord community in the description. And we are helping each other. That's growing really fast, and we are waiting for you guys there. If you like the video, hit the like icon. If you haven't subscribed the channel yet, please do subscribe the channel, guys. That motivates me to create more such videos in near future. That's all for this video. Thank you so much for watching. See you in the next one.